Hey guys, so we're just going to look at a few factoring problems. The first one is 6x squared minus 9x. The first thing I want you to do is look at your flow chart. Of course, you won't have this for a quiz or a test, but I want you to start imagining these questions. The first one should be, is there a GCF? So in this problem, we should see that there is a GCF. So we're going to look for the GCF between 6 and 9. Which is 3. And then the same thing for our variable. So we have an x squared here and an x there. So the smallest amount of x's that we have for both terms is just one single x. So once we have the GCF, we're going to take it on the outside of the parentheses and divide. So 6 divided by 3. We have 2. X squared divided by x, we have to subtract our exponents. We're left with an x. And then negative 9 divided by 3 is negative 3. And then x over x, anything divided by itself cancels out. So our answer is 3x times 2x minus 3. Remember, you could distribute to check your answers. So we would say 3 times 2 is 6. X times x is x squared. And then 3x times negative 3 is negative 9. So we did, negative 9x. So we did do it correctly. Okay, for the next one, we have y to the third plus y squared. So we're going to go coefficient to coefficient, but we don't have any. So now we're going to go variable to variable. So we're going to look at our first term, which is y to the third, and our second term, which is y squared. So the smallest amount of y's that both have is y to the second. So our GCF is y to the second. We're going to take that term, pull it on the outside, and divide out to figure out what's left over in the parentheses. Y to the third over y squared. We're left with 1y, because again, we subtract the exponents when we're dividing, plus y squared over y squared. Again, anything divided by itself is 1. So our final answer is y squared times y plus 1. Okay, so the second set that we're going to look at. In the first example, it's x squared minus 16. So again, the first thing that we should be thinking, is there GCF between x squared and 16? For this problem, there isn't. So we're going to think, is it a binomial or trinomial? We see two terms, so we know it's a binomial. Now we have to say to ourselves, is x squared a perfect square? And is 16 a perfect square separated by a subtraction sign? The answer is yes. So this is considered a dots problem, which is the difference of two perfect squares. So the setup would be our double factor bubble, a plus sign and a minus sign, and we're going to take the square root of x squared. Remember, if it's an even exponent, it is a perfect square. To get the square root of it, we just take half of it. So 2 divided by 1, 2 divided by 2 is 1. So we have x and x, and then the square root of 16 is 4. Same thing for the bottom one. So we have 25, which is a perfect square, and x to the 6th, which is a perfect square since that's an even exponent, and we are subtracting the two terms. So set up our double bubble. We're going to put a plus sign and a minus sign. Now for this problem, we should notice that the number comes first, so our number has to go first before our positive and negative sign. So the square root of 25 is 5. And then the square root of x to the 6th, again, we take half of 6, which is 3. And then for the final example, we have 3 terms. So first question, is there GCF between x squared, 4x, and negative 21? The answer is no. Is it a binomial or a trinomial? We actually have a trinomial in standard form. So let's check out our leading coefficient. So the number in front of x squared is a 1. So since it's a 1 and we have a trinomial, we could use our 1am method. So we want two numbers that add up to 4 and multiply to negative 21. So let's think of two factors that multiply to negative 21. We should be thinking 7 times 3 is 21. And now we have to figure out the signs. So 7 times 3 is a 21. We need one to be a positive and one to be a negative since it has to multiply to a negative. Since our middle term or our B term is positive, the bigger number should get the positive sign and the smaller number will get the negative sign. Because when you add a positive 7 and a negative 3, we get a positive 4. So once we have our two numbers, we're just going to fill them into the factor bubbles. So our variable that we're given is an x, so we're going to use x, and we're going to put plus 7 minus 3. If you wrote x minus 3, x plus 7, you're still correct. I'm just going to go over two special cases that you might see either on a quiz, a test, or on a Regents. So we're given x to the fourth plus 9x squared plus 20. Again, is there GCF between all the terms? The answer is no, and it is a trinomial. So this trinomial, the only difference is that we have it raised to the fourth power with a variable raised to the second power in the middle. So let's go about this as if we would for a 1 a.m. problem. So we want two numbers that multiply to 20 and add up to 9. So we should be thinking 5 times 4 adds up to 20, then 5 plus 4 adds up to 9. So we would put those numbers with a positive 5 and a positive 4. If we used x and only x, watch what happens when we multiply to check it out. X times x is x squared. We would have our 4x plus 5x plus 20 when we distribute all our terms. Altogether, that's x squared plus 9x plus 20. But we need a 4 and a 2. We only have a 2 and a 1. So that's not going to work. What we should be thinking is take our variable of x and x that we placed here and raise it to the second power. Because again, watch what happens when we distribute out. X squared times x squared is x to the fourth. X squared times 4 is a positive 4x squared. 5 times x squared is 5x squared. And then 5 times 4 is 20. So when we combine our like terms, we have x to the fourth plus 9x squared plus 20. And that does work out because that is our original. And the last one that I want to go over is 4x plus x squared minus 32. We should notice something about the given trinomial, and that it's not in standard form. So the first thing we want to do is place it in standard form. So we're going to take our x squared, write that first, then 4x minus 32. From here, we should notice that we have a 1am problem. So we want two numbers that multiply to a negative 32 and add up to a positive 4. So two factors are 8 times 4, and when we multiply 8 times 4, we get 32. But again, we need a negative, so one has to be positive, one has to be negative. Since our middle term right here, that positive 4x is positive, we want the bigger number to be positive. So we have a positive 8 and a negative 4. Once we know our two numbers, we're just going to fill them into our factor bubble. So we're going to put an x plus 8 and an x minus 4. All right, I hope this helped. See you guys later.